Welcome to my Advanced Database Management System course. In this section, we discuss about denormalization, key points about denormalization, maintenance challenges, selective denormalization trade-offs. Let's enjoy. Denormalization is the process of intentionally introducing redundancy into a database schema to improve performance, usually at the cost of data redundancy and potential loss of data integrity. It involves selectively relaxing the rules of normalization by allowing redundant copies of data to be stored in one or more tables. Denormalization is often employed in situations where read performance is critical, such as in data warehousing, analytics, and reporting systems. Key points about denormalization. Performance optimization. The primary goal of denormalization is to improve query performance by reducing the need for joins and minimizing the complexity of queries. By storing redundant data in tables, denormalization can help avoid costly join operations, thereby speeding up data retrieval. Data duplication. Denormalization inevitably leads to data duplication, as the same information may be stored in multiple places within the database. While this redundancy can improve read performance, it also increases storage requirements and maintenance overhead. Loss of data integrity. Introducing redundancy through denormalization can potentially compromise data integrity. Updates, inserts, and deletes must be carefully managed to ensure that redundant copies of data remain consistent and in sync with each other. Failure to maintain data integrity can lead to inconsistencies and inaccuracies in the database. Selective denormalization. Denormalization is typically applied selectively to specific tables or parts of the database, where performance gains outweigh the potential drawbacks. It may involve duplicating entire tables, introducing redundant columns, or pre-computing aggregates to optimize query performance. Trade-offs. Denormalization involves trade-offs between read performance, storage efficiency, and data integrity. While it can improve query response times and enhance user experience, it requires careful consideration of the trade-offs involved and a thorough understanding of the application's requirements. Use cases. Denormalization is commonly used in data warehousing environments, where the focus is on analytical queries rather than transaction processing. It is also prevalent in reporting systems, where complex queries need to be executed efficiently to generate reports and insights from large volumes of data. Maintenance challenges. Maintaining denormalized databases can be more complex than normalized ones. Care must be taken to synchronize redundant copies of data, handle updates and deletes consistently, and ensure that data remains consistent across different parts of the database. In summary, denormalization is a technique used to improve query performance by introducing redundancy into a database schema. While it can lead to performance gains, it also comes with trade-offs in terms of data redundancy, integrity, and maintenance complexity. Denormalization should be applied judiciously, taking into account the specific performance requirements and constraints of the application. Thanks for watching the Advanced Database Management System lesson. Hope you enjoy the lesson. To learn more about Database Management System, please check the next lesson. Never stop learning. Thanks once again to enjoy the lesson.